Good morning, students. In last class, we were discussing about the definition of expected value and how to define the expected value formula for a discrete random variable and a continuous random variable. We were discussing in last class. Today class, we are going to be discussing about the main properties of expected value. Here I am writing the properties under expected value. First of all, how to representing the expected value. Already we are discussing that the expected value we are representing with capital E. And the random variable we are always representing with capital as capital X. In case of discrete random variable, we have to consider the summation. The summation range we are representing the total natural numbers. Suppose in case of continuous random variable, we have to representing the summation can be replaced with integration. The remaining functionalities is as is. Suppose you can take in that discrete random variable case, you can choose the probability. In case of continuous random variable, you have to consider the density function. Now we are discussing about the properties of expected value. In that, the first property, here I am writing the first property is we are able to apply the expectation on a constant. Here I am consider the constant value is A. Constant value is A is equal to A. How to obtain this property? We need to derive the value of small a. That's why I am taking that the fundamental definition of expected value. For providing the proof for this property, you can take in the constant value. The constant value is the x value is A. X value is A according to the definition of probability density function. We can write in the fundamental definition for expected value. But here he is not having, but he is not giving any nature of a value. Why? Because he is just giving the constant A. But how to define that? For this one, first of all, you can write in the continuous random variable expected value is minus infinite to plus infinite x into fx of x into dx. X of x into dx. This is a basic formula. By using this formula, we are able to find in the value of expectation A. That's why here I am writing the x value can be replaced with small a. That's why I am writing expectation of A where x is there without function. Just you can keep the values small a. If the function is there, we are not replacing the quantity. Why? Because the a value is a constant. That's why here I am writing just I am replacing the x quantity is integral minus infinite to plus infinite small a of x of x into dx. In this function, small a is a constant. That's why I am writing outside of the integration. The remaining terms I am writing as it is. A integral minus infinite to plus infinite of x of x into dx. X of x into dx. In this term, the second term is representing the basic definition of probability density function. According to that, the quantity of this function is unity. Let's say here I am writing since integral minus infinite to plus infinite of x of x into dx is equal to 1. From essential properties of probability density function, we are able to consider this one. That's why here I am replacing the 1. Now we can multiply a with 1, we are obtaining a. This is the property of first one for expected value of constant. Now we need to take the second property The second property is can consider one constant and one variable. The variable is a random variable. That's why here I am consider expectation of Ax is equal to A into expectation of x. Expectation of x. How to obtain this one? The same formula you can consider here. For providing the proof for this property, you need to consider the value of x is Ax. Let capital X is equal to A capital X. With this function you consider in terms of expectation value. That's like writing the basic definition of expected value. That one is expectation of x is equal to integral minus infinite to plus infinite x into fx of x into dx. You can write either small x or capital X. Any value can be representing the element in a random variable. Now you can replacing the x quantity with Ax. The expectation of Ax is equal to integral. Where x is there, you can replacing the quantities Ax. Ax, you can take the small x or capital X. The function is fx of x into dx. You can identify here I am not changing in function. I am only make the change where x is there. Just I am keeping the quantity of x. Now I am moving the constant value before the integration. Now I am writing a is before the integration, and the remaining values I am writing as is integral minus infinite to plus infinite x into fx of x into dx. X of x into dx. In this one, the integral portion is representing the basic definition of expected value. That's why I am replacing what the quantity is lying here, the entire quantity, that I am replacing with expectation of x. Expectation of x. This is the second property. The expectation of x is equal to a into expectation of x. The second one. Coming to the next property. In third property, we need to consider the linear equation. For this one, we are able to consider one linear function. The linear function expected value is, here I am consider the linear function is ax plus b. Ax plus b. In this function, small a and small b both are constants, and capital X is a random variable. Capital X is random variable. Now you can able to apply the expectation on this linear function. What is the value you are obtaining? Here you can writing a into expectation of x plus b. We can derive what is the property final value. You can able to take in that is the fundamental definition of expected value. For obtaining this property, I am taking the x values linear equation. Let capital X is equal to ax plus b. Ax plus b. Here I am writing the basic definition of expectation value. Is expectation of x is equal to integral minus infinite to plus infinite. Here I am writing a definition x into fx of x into dx. In this one, here just I am replacing the x value. What is the x is there in this expectation and integral term. Just x can be replaced with ax plus b. Ax plus b. Here I am writing expectation of ax plus b is equal to integral minus infinite to plus infinite. I am only making the change in x term. I am not do any changes in density function. I am replacing the x quantity with ax plus b. into the density function is f(x) of x into dx. X of x into dx. Now you can flip this integration for the summing terms. For first term, I am writing integral minus infinite to plus infinite ax into f(x) into x into dx plus the second quantity is b. For this one, you can take in the minus infinite to plus infinite. Why the integration is coming for this summation combination terms. Those are ax and b. That's why I am giving the integration to the second part. The second part is b into f(x) of x into dx. Now we can moving the a term in the first term before the integration. A integral minus infinite to plus infinite x into f(x) of x into dx. The second term, in this term also the b is a constant. That's why I am moving the b term before the integration. Otherwise you can move this b is outside of the integration. Then you can writing the b integral minus infinite to plus infinite f(x) of x into dx. X of x into dx. Now you can observe the first term is representing the basic definition of expected value of random variable x. Coming to the second term, in the second term, the integral minus infinite to plus infinite of x of x into dx, this quantity is representing the second property in a probability density function. Now I am replacing its equivalent values, then the final value can be changing a into expectation of x plus b into this entire quantity is 1. Now we are obtaining that the third property is expectation of ax plus b is equal to a into expectation of x plus b. Coming to the next property in expectation values, the fourth one is, here you can be able to obtain the expectation of sum of random variables is equal to the summation of individual expectation values. That means we are writing expectation of, already know that the random variables you can represent with capital letters x plus y plus z. Here I am taking only the 3 random variables. Suppose you can have taken the number of random variables, you can representing its individual quantities. These are the independent random variables. Independent random variables. We can representing this random variable expectation values the individual summation. So expectation of x plus expectation of y plus expectation of z. Expectation of z. This property we are mainly discussing when the random variables is independent. And the second property, the fifth property in expectation values is the product of random variables x into y into z is equal to, here in this fifth property we must consider what are the random variables you can representing in expectation value. Each and every random variable is independent. Independent means it is not depending on any random variable. Then only you can writing the individual product of each random variable expectation value. Let's say here I am writing the expectation of x into expectation of y into expectation of z. We can derive that what is the derivation of this each and every property. You can just consider the fundamental property of expected value for a continuous random variable. Then you can representing each and every value in that formula. Then you can writing its equivalent functions. These are how to derive the derivation parts to these 4 and 5 properties. Suppose we need to take the random function. The random function, you can able to consider two functions. Here the 6th property is, you can consider the random function. The random function is having the real values. Here I am consider the random function is g of x. G of x is containing the real values is x1, x2, x3 up to xn. Here why you can call this one is a real value? The function is always containing the multiple number of values. The values is either negative sign or positive sign. That's why here you need to consider one function. The function is a random function. It is containing the real values. Now we can consider the expectation of g of x. Expectation of g of x we can representing in terms of it's a basic formula. Already we have seen that in last class. The same thing here I am writing, integral minus infinite to plus infinite, g of x into fx of x into dx. Fx of x into dx. Just here you are replacing the x position with g of x. Why I am writing here? Here you can able to take in that two functions. And now to consider the two functions, how to writing its expectation value. Here I am taking the 7th property. The 7th property is expectation of g1 of x plus g2 of x. g2 of x is equal to the individual expectation of each and every function values summation. Here I am consider the expectation of g1 of x plus expectation of g2 of x. g2 of x is the one more property in expectation values. Coming to the next one. The next one is we can able to take the expectation value is greater. The expectation value is greater when the x value is greater than or equal to 0. Greater than or equal to 0, the expectation value e of x is also greater than or equal to 0. The reason is, already you know the formula for expectation of x is equal to integral minus infinite to plus infinite x into fx of x into dx. Fx of x into dx. In this formula, the x quantity is more than 0. What about the remaining quantity? The remaining quantity, already know that the value of integral minus infinite to plus infinite is fx of x into dx quantity is 1. This quantity is 1. According to that definition, we are able to define the quantity of x is greater than or equal to 0. Finally, the expectation of x value is also greater than or equal to 0. You can able to prove this property. Just you can take in the basic formula. Then you can writing the x value is greater than or equal to 0. This means equal to 0 and more than 0. Suppose you can take in that 0 quantity here. You can multiply 0 with whatever the functional value is there. That entire quantity goes to 0. Suppose you need to take the x value is 1. X value is 1 and fx value is also 1. Fx value is also 1. You can take in the limitations, the 2 to 3 like, but the quantity is more than 1. More than 1. Why? Because the entire quantity is here 1. You can obtain the integration of this is x. For x, you can take in the limits, the 2 to 3, the higher limit minus lower limit, the quantity is 1. Then you can simply say that the quantity is more than 0. The quantity is more than 0. When I have to prove this property, just you can take in the basic definition. Then you can give the what is the instruction is given in this property. You can mention it. Then you can finally you can say that the quantity of f of x into base quantity is 1. The entire value must be greater than or equal to 0. Coming to the next property, you can able to take in that for a conditional events. The condition means is a comparison. You can able to take in that x1 is less than x2. For this one, you can able to apply the expectation value. The relation you can writing expectation of x1 less than expectation of x2. Whatever the comparison you can take in between any two values, the same comparison is lying when how to applying the expectation value on those elements. See one example problem on expected value. Here is giving some information. The information is containing elements. The elements are x quantities and the corresponding probabilities is given. He is just asking can you able to find the quantities of expectation of x, and the next point is expectation of 2x plus or minus 4, and next point is expectation of 4x plus 5, and last point is expectation of x square. How to find those quantities? Here you can able to simplify that. We must know that what is the properties we are having in expected values. First of all, I am writing the given data. Given data is what the values is representing in this one. That one is a given data. Now the first point. What is the first point? The expectation of x. Expectation of x. In this problem is given discrete quantities or continuous quantities. How to identify that? When I have to give the tabular form and is mention the quantities with the numerical values, we can identify the given random variable is discrete. In case of discrete random variable, we are giving the formula is expectation of x is equal to summation I is equal to 1 to n xi into probability of xi into probability of xi. By using this formula, we can able to give the solution for this. Here, how many elements he is giving and what is the range? In this tabular form, he is giving the elements is a minus 3 to plus 3. Next, in summation, I have to representing the range values are I is equal to minus 3 to plus 3. So xi into probability of xi. Xi into probability of xi. Now we can expanding these summation ranges. Now to substitute these I values, we can expand this entire equation. Now I am substituting the quantities x of minus 3, probability of x of minus 3 plus y. However, and the summation notation, that's why I am using plus sign. And next one is x of minus 2, so probability of x of minus 2 plus x of minus 1, so probability of x of minus 1 plus next you can take the quantity at 0, x of 0, probability x of 0 plus x of 1, probability of x of 1 plus x2, probability x2 plus x3, probability x3. Just I am expanding the equation based on the ranging values. Then you need to substitute the corresponding quantities. Here, what is the quantity is there for x of minus 3? X of minus 3 means the x value is minus 3. What is the quantities available is 0.05. Like this, you can Substituting the corresponding quantities, you can multiply those values, you are obtaining the E of x. E of x. Coming to the second one. The second one is expectation of x plus or minus 4. Plus or minus 4. We are having the property in the expectation values. That one is, after applying the expectation on the linear equation, we can write in expectation of, suppose you can take in the linear equation is ax plus b. Ax plus b. For this one, we are writing the a into expectation of x plus b. Based on this formula, here I am writing 2 into expectation of x plus or minus 4. Already in first point, we are able to find the expectation of x. Here, in this formula is the expectation of 2x plus or minus 4. We are simplifying this one by using the expectation of ax plus b. Ax plus b is equal to expectation of, here you can write in the constant before the expectation, a into expectation of x plus b. Yes, b. By using this property, we are able to simplify this quantity. That is 2 into expectation of x plus or minus 4. Here, we need the value of expectation of x. In previous section, already we are able to find the expectation of x quantity. Just you can substitute in the quantity in this one. You can multiply with expectation of x quantity plus or minus 4. Here we are able to get in the true values in this point 2. Coming to the third point. The third point is expectation of 4x plus 5. The same property we are applying in this one. What is the property is expectation of x plus b. Based on that one, you can able to write in the 4 into expectation of x plus 5. Plus 5, we are able to give the solution for that. Coming to the last one. What is the last one? The last one is expectation of x square. Expectation of x square. For this one, we are writing the formula is integral minus infinite to plus infinite x square into f of x into dx. This is for continuous, but the given data is given in case of discrete. That's why I am writing the formula is I is equal to minus 3 to plus 3 x square I the probability of xi. Probability of xi. In this formula, just you can square the element values. The remaining is as it is. What you can do in first point, the same thing you can repeating in fourth point. But the change is only the x value is squaring, remaining is as it is.